In this problem, we are charged with identifying the oxidizing agent and the reducing agent in each one of the three redox reactions that are shown on the slide. In the case of an oxidizing agent, we realize that an oxidizing agent is a substance which takes electrons away from other substances. So we characterize that by looking at how its oxidation number changes during the reaction. If it gets electrons, its oxidation number will decrease. So we can say that the oxidation number for oxidizing agents decreases. And conversely, the reducing agent will be the thing that gives up electrons, so its oxidation number will increase. So let's look at a reaction A, and first of all we will assign oxidation numbers to the reactants and the products and look at how they change. You should recall that the oxidation number for substances in their elemental form, like iron here, is assigned as 0. The same is true for dichlorine. That's the elemental form of chlorine gas. Oxidation number is 0. In FeCl3, the oxidation number of iron plus the oxidation number of chlorine times 3 will be equal to 0. And so since the oxidation number of chlorine will be -1, we can say the oxidation number of iron plus 3 times -1 will be equal to 0, and the oxidation number of iron will be equal to +3. So +3 for iron, -1 for the chlorine. So now we'll look at the change. Iron goes from 0 to +3. That's an increase in oxidation number. So iron is the reducing agent. Okay, we'll call it red for reducing. That means chlorine must be the oxidizing agent, and it should have an oxidation number decrease. And it does. It goes from 0 down to -1. So it is the oxidizing agent. Okay, so iron is the reducing agent, chlorine is the oxidizing agent. We do the same thing for reaction B. This is a hydrocarbon, C2H6, plus oxygen goes to CO2 and water. Now in the case of the hydrocarbon, we put it over to the side here, the oxidation number of carbon times 2 plus the oxidation number of hydrogen times 6 is equal to 0. And since this is a covalent compound, hydrogen has an oxidation number of +1, and therefore we can say that 2 times the oxidation number of carbon plus 6 is equal to 0, and the oxidation number of carbon is equal to -3. Okay, so carbon is -3 in this compound, and hydrogen is +1. Okay, oxygen's in the elemental form, so its oxidation number is 0. And in CO2, carbon is +4, and oxygen is -2. +4, -2. In water, hydrogen is +1, and oxygen is -2. So we can see if we look at carbon, the oxidation number goes from -2 to +4. That's an increase in oxidation number, so C2H6 is the reducing agent. So we'll call it red here. Oxygen goes from 0 to -2. That's a decrease in oxidation number, so oxygen appropriately is the oxidizing agent. If we look at example 3, we have carbon monoxide. Here, oxygen will be -2, so carbon will have to be +2. I2O5, we have 2 times the oxidation number of iodine plus 5 times the oxidation number of oxygen is equal to 0. So the oxidation number of iodine will be equal to, this is -2, so this is 10, -10, transferred on that side to be +10, so +10 divided by 2, +5. So the oxidation number of iodine is +5. The oxidation number of oxygen here is -2. The products, diiodine is the elemental form, so it has an oxidation number of 0. And in CO2, as we saw above, carbon is +4 and oxygen is -2. So if we look at what changes, carbon changes from +2 to +4. That's an increase in the oxidation number. So carbon monoxide, since it has the carbon, will be the reducing agent. Iodine goes from +5 to 0. That's a decrease in the oxidation number, and therefore it is the oxidizing agent. So by looking at the changes in oxidation number, we can assign the oxidizing agent, which we call Ox, and the reducing agent, which we call red.